Good morning, students. Today we are going to see the topic of loading of lines in transmission lines and RF system. The loading of line, which is literally meaning to impedance matching in a transmission line. Okay. So here the loading of cable is literally it is equivalent to increase of ratio between inductance and capacitance. So first of all, we supposed to know about what are the primary constants of our transmission lines are resistance, inductance, capacitance and conductance. So here the L bar ratio, which is nothing but the ratio between inductance and the capacitance. So in order to achieve a distortion-less line in practical condition, we supposed to increase the ratio between inductance and capacitance L bar C. So this can be achieved by introducing inductance to a transmission line. So by which we can improve the distortion-less line. Okay. So by increasing the inductance value, there are three terminologies are there. So one is lumped loading, fast loading and continuous loading. There are the three methodologies, and here we can directly introduce an inductance to a transmission line, by which you can improve the inductance, and by another methods like by introducing that loaded coil like toroidal cores can be used for loaded coils, by which you can increase the inductance bar capacitance ratio. So this is the toroid coils by which you can improve the inductance in a transmission line. So here I told earlier the inductance loading or loading of transmission line come to under three categories. The one will be unloaded line, lumped loaded and continuous loaded. So unloaded line means where that ratio of inductance and capacitance are not properly maintained. So in which you could see that in the earlier frequency ranges there will be a sudden rise in the performance, and it gets saturated over a period of increasing in frequency. But in case of lumped loading, the attenuation is very less. You could see that the attenuation between unloaded line and lumped loaded line. So there are less attenuation till fewer frequencies, and later on in this condition, when the frequency increases, the attenuation also increases. So here in high frequency ranges, you cannot use lumped loading concept. You could see that there is a attenuation also increases. But in the case of continuous loaded condition, you could see that the attenuation is very low comparing to other methodologies. For higher frequency also the attenuation is very less, so that only the most of a condition the continuous loaded conditions are being used. So there are three sort of loading conditions are there: lumped loading, continuous loading and fast loading. So in case of lumped loading, so lumped loading is simply you are introducing an inductor between a transmission line. For example, if you are taking 50 meter of a transmission line followed by an inductor, then another 50 meter length of transmission line will be connected. So through which you can reduce the distortion in a transmission line. Next is continuous loading. So the continuous loading is by placing tapes of magnetic material or permalloy or iron core over a transmission line. You could see that here it's like a loop of coils. So it will be wound around our transmission line. So it made out of magnetic tape. So that due to that magnetic tape wound over our traditional transmission line, there will be an improved inductance. So this is one of a continuous loading methodology where higher frequency transmission line using this sort of continuous loaded line, because you could see that in higher frequency the attenuation is very less under this methodology. Then another method is called as patched loading. So in the patched loading there will be two methodologies, because by combining the lumped loading and continuous loading. So here the inductance value will be increases if there is an introduction of unloaded line. For here you could see that for over a long period of length there will be a loaded line and followed by unloaded line. So that's why it is called as patched loading methodology. So comparing to lumped loading, patched loading, the continuous loading methodology we followed in a real-time application.